In today's video, I wanted to introduce myself, share a bit about my journey, and give you some little bit of context about the kind of content you will see on this particular channel. So this is my very first intro video. So I thought it would be perfect place to explain my niche, what I'm passionate about it, and what you can expect from me going forward. So my main interest and background is in low-level systems engineering and its internals. I have been doing low-level systems engineering and its internals like quite been a long time. It's been like 6 to 7 years. I have been doing C, C++, and x86 64 assembly, in free time as well, and been doing Rust for since 4 years. So I think this niche is quite of my passion, right? It's like doing since childhood, and distributed systems is kind of thing where I have been learning distributed systems by doing open source contributions and by reading some important concepts from distributed book that is called DDIA book, that is wonderful book. And high performance engineering, this is the peak book, right? This is a peak niche to me because high performance engineering involves, right, you need to really understand about hardware very well. If you really want to squeeze every bit of performance from that particular machine, you need to have a good background about that hardware stuff, and that is my passion as well. Now I'm diving deeper into this inference niche, right? Inference niche here. Now you would ask me why I'm diving deeper into inference niche, because this niche is quite a combination of these all things here. These all things. I'm not saying that you should be very, very good into all these kind of things. No, not at all these, but you should have a good background into these niches, right? Little bit about like low level systems engineering and its internals, distributed systems and high performance engineering even have a good high school physics. I'm saying physics because it would be needed, because resources are very less, right? We need to use resources at most efficient as possible. If we talk about from physics perspective, take an example like we talk about dynamic power in chips, where power is directly proportional to CV square F, right? Where C is like capacitance, V is for voltage square, and F is for frequency. So if you don't understand physics, you wouldn't be able to find this this particular system's maximum threshold peak value, right? And this is very important. If you really wanted to find a maximum threshold peak value, you need to understand the physics very well. Not very well, but at least a good understanding of this. And also hardware's knowledge. It's really, really important into this inference niche. If you have to really understand CPUs and GPUs, and we would also go through these hardware concepts of CPUs and GPUs into my coming future videos. It would be super, super duper fun, right? And when you do all these things, you would feel like I'm Tony Stark. It feels like I'm child again, and you would love to do all these kind of topics, right? So it's super, super fun, super passionate thing, and you would enjoy every bit of things. Now, from my own perspective, inference is a niche, right? It's highly dominated with systems engineering, 75 and 25 from my perspective. It involves 75% concepts are systems programming and 25% are ML heavy concepts, to be honest. It doesn't require you to become really great at ML. No. ML is just like, little bit of ML knowledge is required, not much ML. I will tell you little bit like these concepts here, like neurons, MLP and fully connected layers and forward pass, loss function, activation function, parameters and activations, and all sorts of things. These concepts are required because, if you wanted to read some kind of white papers or research papers from the inference perspective, you should have a good context of this ML concepts. This is a quite good, this is a quite big, big list of ML concepts. I didn't tell you here because it would be super overwhelming for you and you would get scared. So that's why. Now, what kind of content I would create? I would mainly create content on inference. Inference is divided into prefill and decode. Prefill is compute bound and decode is memory bound. We would understand this thing very deeply in the coming video because these are the fundamental concepts, very fundamental. So in inference, mainly I would focus on ML performance inference engineering, distributed inference. This is very, very beautiful. Distributed inference stuffs, right? We would understand the NCCL stuffs, at large scales. We would read some kind of important research papers and white papers as well. And high performance inference CUDA kernels. So CUDA kernels is also a broad niche. I would only go through this inference CUDA kernels because it's connected with my niche and it would be fun. Now, I want to give you a side note to you guys here. I would mainly focus on building the system's intuition, reasoning ability, architectural design decisions, not on coding or programming stuff. No, I won't teach you how to write programs in C++, Rust or C, whatever. No DSA lead code problems. No, we would purely focus on building our system thinking from first principles. This is the very, very important thing. Now, come to the point here. Second thing here, I want to talk about it. That is called inference is quite scattered on internet. Like literally, when I got started with inference, it's very, very scattered. I want to make it as consolidated as possible. That's why I started to make videos on inference, right? That's what I have planned. I would try my best to make it more enjoyable, more easy with pure technical knowledge. And I would try to make the concept feel alive by using, analogies, by reasoning from first principles, and also a little bit more fun thing. Also, I'm doing this because it's my passion. And I also wanted to become good into this inference stuff, because when I make videos, it would force me to literally understand the concepts very well. And because if I don't understand the concepts, how would I explain to you? How would I share, teach, explain, whatever? That's why I'm learning this. I'm doing this because, making videos is not just one-sided. It's two-sided. I would make videos, you guys would give me feedbacks, whether it's negative or positive. I would work on those feedbacks. I would also learn, and you guys also learn. So this is like two-way communication. Now you got my point here. Now, what kind of content we would cover here? The content we would cover, the book that we would mainly cover here is this, like these three books: Computer Architecture, Quantitative Approach by L. Hennessy, Operating Systems, Systems Performance book by Brendan Gregg. These three books are incredibly fundamental books. Incredibly important. Trust me. These two books are incredibly important. I'm not saying why, but it's super important. If I talk about like computer architecture, you should be able to understand the memory hierarchy design, right? Cache level stuffs, the thread level parallelisms, and concurrency stuffs like instruction set principles and all sorts of things. These are very, very important concepts. If you understand it well, you would see those systems from the systems level perspective engineers, right? That's why. And if I talk about operating systems, in operating systems, the concepts like virtual memory, concurrency, persistence, virtualizations, process API, and all sorts of things are super important. So we would also understand those concepts very well in operating systems. And in systems performance book, this is the Bible. I literally wanted to say this is the Bible for any performance engineer. This is incredibly important book. Like, understanding how to profile it, how to read those, graphs and all sorts of things, the benchmarking stuffs, the performance, the F-trace and BPF, all sorts of things. We would do all these stuffs. It's super fun, super exciting, and super important. Trust me, this is super important. If you understand it well, you would do wonders. Now, let me give you a little bit background here. I'm assuming that you all guys have a little bit C++ background, right? I'm not saying that you should have a complete C++ background knowledge, just a basic like functions, arrays, the namespaces, the const and all sorts of things. And even you should also have a good background about like templates, function templates, inline functions, and RAI, resource acquisition, is initialization stuffs, and moon semantics, right? These much is helpful for you to write, the CUDA kernels. Definitely high performance inference CUDA kernels. So this would help you a lot. This is very, very important, right? I'm not going to teach you C++ because it would be easy. If you go and give some little bit time to C++, you would easily learn it. And Python just is a plain English, right? It's not difficult. You can easily learn. You would only use it for fast iteration and implementation. So what I would do, wherever I see the concept and I feel like, yeah, this concept needed some little bit, implementation, So I would, implement that stuff, and I would share a repo, and I would explain the code from the system's perspective, like from first principle reasoning, why I did this, why not, and all sorts of things. Now we would also go through NVIDIA GPU white papers. So yeah, it's very important, the NVIDIA GPU white papers. So I would mainly go through like, GA102 and GA100 white papers, which is standard. I have RTX 3060, which is based on GA106 Ampere architecture, right? So I would mainly focus on like Ampere and Hopper architectures. Like, yeah, right now Blackwell is also an industry standard, but just for right now, we would mainly focus on these architectures very well, because once you learn the concept very well, the concepts are fully transferable. So focus on building strong fundamentals. Now, once you get the fundamentals, it would be easier. Now, we would also cover deeply about distributed inference, right? We have already talked about it. This is very important. We have multiple nodes, right? Like multiple nodes act as like a physical, hardware, physical server hardware, right? Where, multiple nodes, physical server hardware. And in that physical server hardware, we have what? We have, GPUs or multiple GPUs, CPUs or multiple CPUs, storage and networking, all sorts of things. So we would do all these things, right, in the coming future videos. So it would be a lot more fun. Also, NCCL, that is NVIDIA communication, NVIDIA collection communicative library stuff. And all to reduce to all sorts of things. We would also do this. Networking topologies like, inside that server, this is like NV link, NV switch. Outside, like, InfiniBind, Ethernet, and all sorts of things. These topologies will definitely help you a lot in distributed inference stuff as well. And now some important white papers will do also, right, in the coming videos. So don't worry about it. And we would deeply understand the inference serving engines, right? It is very important right now, because when we understand these things, it would help a lot and improve our thinking about inference very well. Like VLLM, which is standard, industry standard, SGLang, and a little bit about llama.cpp. So it would be fun. And last but not the least is high performance inference CUDA kernels. As I said, CUDA kernels is a very broad niche, right? There is a training kernels and all sorts of other kernels as well. So we would only focus on inference CUDA kernels, right? And we would try to write high performance inference CUDA kernels, right? And we would mainly spend a lot of time on profilers like Nsight Compute, Nsight System, and 80% of our whole time goes on profilers, reading it, understanding it, analyzing things. And then we would decide like what kind of optimization techniques we should use according to that situation. Along with that, we do also understand and do these things like PTX and SAS on godbolt.org. This is very fun thing, right? You would feel like you're doing assembly again. And also, in the last, we would go deeper into the CPUs and GPU hardware. Trust me, this is the main thing. GPUs and CPUs hardware. This is going to be super real, right? We would go deeply into these stuffs, right? We would go understand the memory hierarchy of CPUs and GPUs stuff, right? We have like the very registers, L1, shared memory, L2, and all sorts of the HBM stuff, right? Along with that implementation repo, as I told you, along with that implementation repo and benchmarks with real numbers, like wherever I see the concept, yeah, it needs an implementation repo, benchmarks, real numbers, and all sorts of things. I would definitely share you. And also I would create deep technical blog, so don't worry about it. So because it takes all these things takes lots of hard work, lots of time. And so don't expect content very fast. I would try to make content at least one video 1 week, or maybe 2 week video, like once a week, as I got time, because creating content like these takes so much time. I want to create content as good as possible. I would try my best to teach and share all the concepts. So please keep on learning. Thank you. Stay tuned and just keep learning.